Hi, I'm Debbie with Nixene Publishing, and we are resuming our conversations with very interesting people in the graphene world. We're coming to you from Florida here for myself, Yorkshire, England for Adrian, and we have a special guest today, and that is Dr. Chris Griggs, who is coming to us from Vicksburg, Mississippi, and he is someone who works with the U.S. Army ERDC, and he's going to tell you a lot about the cool things that they're doing over there. Hi, Chris, welcome.
Hi, Debbie, thanks. Yeah, so I'm Chris Griggs. I am a senior research physical scientist at the U.S. Army Engineer Research and Development Center. We're in the business of solving problems, and graphene is something that we've been interested in working with for a while. We've been active for about 5-6 years now, and we're seeing a lot of application space for a lot of the challenges that we're facing, both for military and civil applications.
It is great to have you here, Chris, and we're excited about the things that you're doing over there. We've got a lot of news in the graphene world from you. Can you tell us a little bit about what you've been doing and some of the things that you can tell us about?
Sure, yeah. So I work in the environmental lab. So we look through that lens in terms of environmental, mitigating environmental hazards and contaminants, and looking at, pollution sources and things like that. So a lot of what we do is develop chemistries and novel materials and processes for treating complex waste streams. And so graphene has found its way into our portfolio, both in the media and the chemistries in terms of what we've been using to clean certain types of water. But we also are looking through a bigger lens too, is that, from a chemistry point of view, that, graphene is carbon, and carbon is also an issue. So I think that one of the things that we're really excited about is the opportunity to use graphene and advanced carbons, both and other 2D materials, both as a mechanism and a media to clean water, air, and other matrices, but also to harness waste forms of carbon and transform them into graphene to something that's usable. So it's basically both a source and a sink. And so I think that we can use it as a feedstock that would ordinarily be a contaminant that would be landfilled or find its way into the environment, or we also can use it to produce advanced materials. So on our environmental side of the house, it's a win-win.
Chris, can you tell us a bit about that, the shrimp stuff that you were playing with?
So that's still, so simpler is always better for us. And so, and we're the environmental lab too. So we always like to use, in my group, we like to start out with the most environmentally benign or renewable type of options in terms of our materials, because we don't want to attack an environmental problem with another secondary environmental problem, right? So we use a lot of bio-based materials, and one of them that we really like working with is the biorenewable polymer Chitosan, which is a derivative of chitin, which is the second most abundant biopolymer on the planet, where there is an immense amount of seafood shellfish waste that comes out of that industry. And it's normally a liability for them, but it's actually a very useful polymer. And for us, it's two things. One, the chemistry is very simple. It's aqueous, so we can do it just by tweaking the pH, which is a huge thing in terms of the polymer chemistry, in terms of making it simple. The second thing is, just by trial and error and just through serendipity and luck and projects converging together, we found that Chitosan and graphene oxide are extremely compatible.
Chris, tell us what happened when you took this shrimp Chitosan graphene composite and put it down the sink. What happened?
Yeah, so we typically frown on dumping things down the sink, but sometimes these things happen. We actually do have mechanisms in the lab to to deal with that. But yeah, so it was funny because one of my researchers was working heavily with it over a stainless steel sink and hood. He's a messy researcher, let's put it this way. So he's very good, but he's very messy. So when we have tours and inspections, we have to go behind him and make sure that we've cleaned up after him. So, but anyway, we basically went in and we saw it was sticking to the stainless steel, and he said he couldn't get it off. And I said, well, why is that? And he's like, I don't know. I've scrubbed it and scrubbed it. It won't come off. And so one of the things that's like, these are the types of scientific observations you need to look at. It's like, I mean, coating something like the stainless steel is not trivial, right? You know what I mean? And if we had intentionally tried to do it, that would have been a problem. So I can see definitely our platform or our baseline material that we use, it obviously has a coding space. So these are the types of things on a day-to-day basis that, you know, or it looks like it's a problem and we just made a mess. We're like, wait a second, this mess is actually important, right? You know what I mean? I'm glad you can't clean it up, you know what I mean? Because I'm glad it won't come off, because, you know, there's certain applications where we don't want it to come off, right? You know, so if we put a coating on there. So I can see that having a much broader application space in terms of, you know, coatings, which is the big deal, you know, so.
Yeah, me too. I mean, I think it was Asimov that said that great leaps forward in science are not eureka moments, but a scientist sort of observing something and going, oh, that's funny, which is just what you said.
Thank you so much for your time, Chris, and for the conversation. You and Adrian are great to listen to when it comes to this. I appreciate it. We'll look forward to hearing a lot more from U.S. Army ERDC and Dr. Chris Griggs. Thank you.